Okay, partial fractions. We're going to start off with type 1. All of the other types are just some sort of complication on top of these ones. So this is the bread and butter of what we're going to be doing this week. We're always going to be starting off with some sort of fraction here. Now notice that the fraction has a higher order, so it's order 2, it's quadratic, on the bottom than it is the top. That's going to be a common theme throughout all of these. What we want to do with them is to write them in the form of two smaller fractions added together. So in this case, we want it to be a over x plus 1 plus b over f3x plus 2. We want to pick the numbers a and b so that this is the same as this. Now, partial fractions have many uses. We're not going to be talking about the uses yet this lesson. We're just going to be talking about how we do the method. It's going to be the same each time. So let's have a look at this board. What we're going to be doing, if we look at the top here, I've just written out this thing equals this thing. It's just the question. So that thing equals that thing. We can copy it down. Now it's a bit of a strange symbol in the middle here. It's the identity symbol. We met it back when we were doing trigonometry. It means that we want this side to be equal to this side for every value of x. So if we put it in x equals 1 or 2 or 3 or 4, we want that this side is exactly the same as this side. If you don't really need to worry about the identity symbol. We will talk more about this back when we're in natural class, but just copy the notation for now. Right, if you look at this left-hand side, if we factorise the bottom, just like we did in the first video, we get this thing. And if you look at this factors, x plus 1 and 3x plus 2, you'll notice that they're the same factors that we had on the bottom of those fractions. That's no coincidence. In general, these bottoms here, the denominators, are going to be equal to each of the individual brackets that you get. If we do a bit of rearranging on this, to add two fractions, we need the denominators to be the same. Well, what we can do to a fraction is we can times the top and the bottom by the same thing, and the same with this one, so that they both have this denominator on the bottom. So if I times the top and the bottom of this one by 3x plus 2, and I times the top and the bottom of this one by x plus 1, then we get this thing here. All I've done is I've squidged together these two fractions. If you look, the bottom is the same as the bottom over here, and the top, well, is whatever the a was multiplied by this, plus whatever the b was multiplied by this. It's like we cross-multiplied. Both of these sides of the identity have the same denominator, and so we don't really need to worry about it. It's the same thing here and here, so let's just cross them out, and we end up with this line at the bottom. Now practically you can jump straight to it, because this side here is whatever we had on the top, and this side here is that multiplied by that plus that multiplied by that. This is the thing we're going to be using. Now we want this to be true no matter which values of x we put in. If we tried putting in some values of x, say we put x as 0, then on this side we get minus 1, on this side we get a multiplied by 2 plus b multiplied by 1. The problem there is that we have an equation with both a and b in it, so we can't solve it. Instead, if we pick the value of x that we're going to plug in carefully, we can make it so one of these brackets goes down to 0 to cancel out a letter. I picked x equals minus 1. If we look at this bracket, if you put x equals minus 1 into here, minus 1 plus 1 goes down to 0. And so it would just be b multiplied by 0, which would just go. That's the tactic here. So if I put x equals minus 1 into the whole thing, this side, minus 1 minus another 1 is minus 2. This side, a multiplied, well, 3 times minus 1 is minus 3, plus another 2 is minus 1. And this has gone. This is an equation with only one letter left in it. It's a. This bracket goes down to minus 1, so we've got minus a. And then times it by minus 1, we get a equals 2. We found one of our letters. We can do the same by plugging in a different value of x to find out b. If you have a think what value of x we need to put into this bracket to get it to 0, well, it'd be minus 2 over 3, minus 2/3. I've done it on this board. So if I put minus 2/3 in, let's just have a look at what it was. Minus 2/3 minus another 1 is that thing there. This bracket goes to 0, and then this is minus 2/3 plus 1. Well, the a's have now cancelled out. Evaluating this, feel free to use a calculator because there's some letters and some fractions around, but we get that b is minus 5. Once we've worked out a and b, if we look back at the original question, all we have to do is replace A and B with the letters we found, which is what I've done here. A was 2, B was -5, and so we've done. Now I've put an alternative form. If you look at how this is written and how this is written, plus -5, it's the same as -5. I've just brought the minus out. Either of these is fine. If you stick it into like calculators or online calculators, it will give you this form. It's a bit neater, but either of these is a fine way to write it. So the tactic here, we started off with this thing here. Sometimes you had to factorise the bottom. We got down to the key line, which is on this one here. The top of this thing equals the cross multiplied of these things. And then we stick in values. You can stick in whichever values you like, but the good values to stick in are the values of x which make one of these brackets equal to 0. Work out A and B, and then at the end of your question, your last line will be you writing out this, but working out what A and B are, putting them in. I've got one for you to have a go at. So, similar thing, the numbers should work out nicely. You're expecting nice whole numbers if you've done this right. Write this thing in the form this thing. I'm going to go through the answer in a minute, so pause the video and have a go. Okay, now notice that this thing already has the bottom factorised. So, writing out the key line, it will be whatever the top was equals, got it here, whatever the top of this line was, 9x minus 33, equals that multiplied by that, plus that multiplied by that. We can stick in some values. If we put x equals 1 in, this bracket will go down to 0. And so x equals 1 is this side and this side. We get minus 24 on this side. This bracket comes to minus 6 because it was 1 minus 7. And this bracket goes to 0. Well, this is minus 6a. Divided by minus 6. Ooh, I've made a mistake there. That should be a 4. Cool. Right, next one. Putting in 7 into this one. Cancels out that bracket. Putting in 7 into this one, well 7 minus 1 is 6. This side is 30, and then divided by 6 gives 5. I'm just going to correct my mistake from earlier. If that's a 4, then A was 4, sorry about that, and B was 5. This is just the original question, but with me sticking in the values for A and B. Usually, they will be nice whole numbers. If you've got something fractional, it's in these initial easy questions, it's probably that you've gone wrong. We will be complicating these in different ways throughout the week, and sometimes they will get fractional later on. Right, cool.